So, all right. So let's see, we have this week and the week after next week left, right? And we still got the entire fall break off, if I recall correctly, right? Is that how this works? Okay. So entirety of the fall break off. So, okay. At this point left, you hopefully you're finished with your cheater, you're finished with cheater hangman and everything beforehand. With the sorting assignment, really what you want to do is definitely automate your data collection. So like, you don't want to have to manually run it on like size 124 and then size 248 and then size 5096 or whatever. You want to make it so that you can, that it will generate all the samples that you need for you in one go. So that makes it very easy that if you made a mistake to fix that mistake and then dump out a whole bunch of data without having to, spend like 10 minutes generating all that data again. Automate what you have to do. Okay. So with regards to so we have two more assignments aside from the sorting assignment, which is we have the graph assignment and the other graph assignment. So first graph assignment is worth 50 points as opposed to 100 because it's not as much work as a regular assignment. The entire point of the first graph assignment is to make sure that you have a external library that does graphs that you can work with. If you're working in Java, I highly recommend using Jung or Jung, I don't know how they pronounce it, Java Unified Graph, Java Unified Graph thing or whatever, I don't know what it stands for. Acronyms are silly. You start with what you want and then plug in whatever you need afterwards. The main thing, and if you're working Python, you want to use NetworkX. But the point being is that the first graph assignment serves as a way for you to get practice using that external library. So you aren't going into the second assignment, which is the real graph assignment, cold, because otherwise the second graphic assignment would just be a nightmare. Because you're trying to do a problem while you're laying the graphing library and trying to debug a bunch of problems with regards to your graphing library. So the first problem is essentially just getting your graph set up, and you prove that that you're able to work with your external library by doing a depth first search or a breadth first search. And I'll use Python coding or rather pseudocode or Python-ish kind of code right over here for a sec to kind of give you just a bit of advice on how to do that, on how you write your breadth first search or your BFS or DFS. Give me 1 second, I'll share my screen. Okay. Oh yeah. So, well, again, I'm gonna just mention that like viruses are going around. You do have, COVID, you have influenza, and you have RSV going around all kind of at once. So if you are, and then we got Thanksgiving next week. So if you're not feeling well after Thanksgiving, stay home. That's fine. I'll understand. Okay. So what you want to do is you'll want to make your graph, and then you'll want to make your function, and I'll write it in Python here, which should be easy enough to understand. You'll want to write your BFS function to work like this, where you take in your graph as an argument and then your starting point as an argument. Okay, to do your breadth first search. So that way those are provided, you don't have to search for those arguments when you're doing so. Similarly for DFS, you want to provide your graph and your starting point. If you're doing it in Java, it's going to look something like this. you're doing it in Java instead, it's going to look something like this: public static. And you can, public static list of vertice, list of V, where V stands for vertice, static V E, right? List of V vertices is the return type B, and then we do BFS. All right. And it will take in a graph of vertices and edges. Graph being the interface and used in Jung for that gets implemented to create like your sparse simple graphs. And then V starting point, or V start. Right, and it will look something like that for your for what you want to do in your with Jung. With Jung, by the way, to iterate over to what you'll want to do often is iterate through a node's neighbors. And it's a lot, I'm working off of memory here, but the way that works is to iterate over neighbors. It would be something like graph dot get. It would be for every V neighbor in graph dot get neighbors and what this would allow you to do is that this would iterate through every neighbor. So given a target node, be it the start or some other part of the algorithm, this for loop is what you use to iterate through all that node's neighbors. I may be wrong about the function name. Might be like get underscore neighbors or something. It might be get neighbors or something. But this is the general form of what you need. Given the neighbors, get the name. This will give a collection of those, and then since it's an abstract collection, you iterate over it using the for each loop. Just like you have to iterate over keys in a dictionary using the key set. But overall, because graphs are so abstract and the implementation you're able to use is so abstract, you're able to pretty much implement the pseudocode so long as you can use the proper words for abstracting it. BFS will be a bit easier than DFS because most implementations of DFS are going to be recursive. You don't have to make your diff for search implementation recursive. You can use a stack instead. You'll need to have, if you do make it recursive, you'll have to have a second recursive method where that actually does the actual recursion, that you pass the information you want to keep that every recursive call should know, such as like all the nodes I've already seen or visited. You want to pass that information along, because otherwise every recursive call will start out fresh. Yeah. So just simply with regards to illness, also if you get ill in such a way that prevents you from like completing your work in a timely manner, please let me know. Because at this point, so long as you've done your work, it's very easy for me to, especially if it's like just being ill prevents you from like finishing off the semester. That's easily solved with an incomplete, which you just simply, especially if you, again, have been doing everything you need this semester, all we say is, okay, once the student's feeling better, they finish their work and the incomplete is actually just replaced with your grade. Okay, so again, if you get sick, don't stress out about it, and certainly don't come to the final if you're sick. We can make that up very easily. Okay, Zoom is a thing. I can proctor you over Zoom. It is not. It has become a lot easier. Okay. Any questions before I move on? Okay. So Thursday, I plan on going over something that I won't be covering on the exams called small world networks. Small world networks are, small world and scale-free networks. We'll also look at how those kind of things came to be and the interesting fields you get, that basically graphing has come out of. Most people will point to the, bridges of Königsberg as kind of a point for graph theory, but also modern graph theory, where we're thinking about relationships between people, is important. Just to be clear, has everybody had exposure to graphs before this? Yeah? Anybody not had exposure to graphs before this? So you've not had exposure through the math concepts class yet. Okay, so no vertices and edges yet?
Maybe.
All right. So so again, with my videos, I assume that you come in knowing nothing, but so just be sure to watch those videos extra carefully. But most of your textbooks haven't really updated to this fact that graphs are all about relationships. Basically, your nodes are your things, and vertices your nodes are your things, and your edges between them represent how they that they have a relationship. The specific graph determines what the things are and how that relationship is defined. We see this with Facebook. We see this with the self-imploding network formerly known as Twitter. We've seen this with Instagram, where basically you have a follower model. Those are all kind of graphs that can be that basically show relationships. Places can have relationships, such as distance between them. So just keep that in mind if you're having trouble abstracting it out. It's all about just what relationships are. And if you view that, it becomes a very more versatile, because typically your textbooks will view it as kind of distances or costs between things. All right. So after this, the last two lectures, what we'll do when we get back, because you'll have basically spent the, look, I'll be honest, I expect you to do exactly as much work as I usually do during Thanksgiving break. I expect you to do as much as I normally do, which is absolutely nothing. Or saying that you're going to do some work and then spend basically all of it except for the Saturday and Sunday before, where you suddenly realize you haven't done any work, and now you really need to get all that work done. I'll actually be working a lot, but honestly, I don't expect that you'll be doing any work during the break. So the timeline for that is accordingly. That being said, you won't really have time to work during class during Thursday and during the next Tuesday and Thursday, because I'm planning on using that time for final exam review, because I think most of you would find that more valuable, right? I will not. So another thing is that I will not be sending out practice final exams. Instead, what we're going to do is that we're just going to grab a bunch from other universities and go through them. Or so either real finals from other universities or the practice finals. I'm a big fan of the data structures final exam from Harvard. That's a pretty good one. It covers a lot of concepts that we cover. And you'll find that that's the case for most data structures class. There's sometimes some bleed into the algorithms class, and sometimes some bleed from the object-oriented class based on how the specific curriculum is designed. But for the most part, you're going to be dealing with linked list and trees and that kind of stuff in most of these. Again, I think we checked that it's like this. It's not the first week of finals, but Tuesday on the second week of finals, right? Yeah, and again, I'll send out that announcement as we get closer to the final exams. Okay. But again, a lot of times we get low grades from the finals. Or when students get low grades, it's because they didn't understand the material in the first place throughout the entire semester. They didn't show up the entire semester, or they were just so exhausted from all the previous finals. And that category is the most common reason for students doing poorly on the final exam. So please, pace yourself. Again, if you have professors if you have 3 more exams in a single day, tell them one of them to move. That's your right as a student. And if none of them, if none of your professors exceed to that demand, that the set path for you is to go over their head and go to the dean of student, go to one of the deans for that, who will then force them to move, or should. All right. So with that, I will let you get to work.